Picture this. You're walking down the stairs into your basement, or maybe you're just opening up that utility closet in the hallway, to grab a broom.
Ooh, and your stomach just instantly drops.
Right, because right there, just creeping out from underneath your furnace is this slow, dark puddle of water. I mean, it is the universal homeowner nightmare.
Oh, absolutely.
Immediately, all those alarm bells start ringing in your head. You see water, you see this massive metal box that controls your home's climate, and you just think, well, that machine is completely broken, and my entire day is derailed.
It's a very visceral reaction. We're completely conditioned by, like every other appliance in our lives, to believe that whenever water escapes a machine, whether it's a dishwasher or a car engine, a catastrophic failure has occurred.
Yeah, water where it shouldn't be is always bad news.
Right, but the reality of modern home systems is actually far more nuanced. So, to help us navigate this, we're pulling from a highly practical, incredibly grounded guide today.
Which is exactly what we need for this deep dive. Our mission here is to take the panic out of that exact puddle. We're going to decode what that water is actually trying to tell you. And our source material today comes from Dave Hartzell.
Yeah, out in Kingfisher, Oklahoma.
Exactly. He is a NATE-certified master HVAC technician, and he brings exactly 47 years in the trade to this guide. 47 years of seeing it all.
Which is a massive amount of experience.
Yeah. But I have to pause you right there for a second. NATE certified. I mean, I see that acronym thrown around on the sides of service vans around town, but what does it actually mean for us as homeowners?
It stands for North American Technician Excellence. Think of it as the absolute gold standard for HVAC professionals.
Oh, okay.
Yeah, it requires rigorous ongoing testing on the actual physics, the electrical engineering, and the mechanics of heating and cooling systems.
So it's not just a basic weekend course?
Definitely not.
Yeah.
So when someone with that level of certification, coupled with exactly 47 years of hands-on experience, writes a guide, I mean, they aren't just giving you quick fixes. They're looking right past the surface symptoms and analyzing the entire system.
Okay, let's unpack this. The immediate assumption you, me, pretty much every homeowner makes is that water pooling on the floor equals a broken, leaking machine.
Sure.
It's a logical leap, right? Water is escaping, therefore a seal is busted, a pipe is cracked, the whole unit is failing. But Dave's guide completely flips the script on that panic.
It really does, because to understand why the panic is usually misplaced, we have to look at the evolution of how we heat our homes.
Okay.
If you have a modern high-efficiency condensing furnace, that puddle on your floor actually begins with the furnace doing its job absolutely perfectly.
Wait. You're saying a modern furnace is literally engineered to create water?
Yes. It is designed to do exactly that.
That sounds like a massive design flaw, honestly. I mean, water and high-voltage electrical heating equipment shouldn't really mix, Why is my heater intentionally making water?
Well, it all comes down to basic chemistry and just this relentless pursuit of efficiency. Let's look at what's actually happening when your furnace turns on.
All right, lay it on me.
So if you use natural gas, your furnace is burning hydrocarbons. When you combine oxygen with those hydrocarbons and ignite them, that chemical reaction produces heat, carbon dioxide, and surprisingly, a massive amount of water vapor.
So the fire itself is actually creating moisture.
Copious amounts of it, yeah. Now, in an older, standard furnace, the process was straightforward, but incredibly wasteful.
How so?
Well, it burned fuel to create heat, but a huge percentage of that heat never made it into your living room. The system simply took all those hot combustion gases, including all that water vapor, and sent them straight up a metal flue and out of the chimney.
Oh, wow. So just right out of the house.
Exactly. The gases were so incredibly hot that the water stayed in a vapor state the entire time.
Yeah.
You were essentially just wasting energy heating the outdoors.
Which is terribly inefficient.
Very. Enter the modern condensing furnace. Engineers realized that, throwing all that hot exhaust gas into the sky was a huge waste of perfectly good thermal energy.
Right.
So they added a second heat exchanger to the system. Think of this component as a thermal sponge.
A thermal sponge, I like that.
Yeah, it takes those hot exhaust gases and routes them through a secondary maze of metal tubing. This squeezes every last possible drop of heat out of the exhaust and pushes it into your home's ductwork before the gases are allowed to leave the house.
So it's extracting the heat that the first round completely missed.
Precisely.
But, because it's pulling all that thermal energy out of the exhaust gas, the temperature of that gas must drop drastically.
Yes. And that temperature drop is where the physics really kick in.
It makes me think of being a kid in the dead of winter. Yeah, you get right up close to a cold glass window and you exhale. Your breath is warm and it's full of moisture, but the second it hits that freezing glass, it cools down so rapidly that the invisible moisture in your breath condenses.
Right, it fogs up.
Exactly. It turns into actual water droplets right on the paint.
That is a brilliant way to visualize it. So inside your high-efficiency furnace, the exhaust gases are your warm breath, and that secondary heat exchanger is the cold window.
That makes total sense.
The furnace cools the combustion gases so effectively that the moisture suspended in them condenses back into liquid water. What's fascinating here is the sheer brilliance of this engineering.
Yeah.
The furnace is supposed to make water.
Wow.
Yeah, when you see that it's producing condensation, it is the ultimate, undeniable proof that the machine is extracting maximum thermal energy.
So it's not a bug, it's a feature.
Exactly. It proves that you're not wasting fuel. The water is actually a badge of honor for a highly efficient system.
Okay, I am following the logic, and I can definitely appreciate a genius piece of machinery. But I have to push back a little here because this brings up a very practical, very urgent problem.
Which is the puddle on the floor.
Yes. If making water is a sign of this incredible engineering, why is it currently ruining the floor of my utility closet? I mean, if it's designed to create this indoor rainstorm, where is all that water actually supposed to go?
That is the million-dollar question, right? That pivots us from understanding the thermodynamic design to examining the physical plumbing.
The aqueduct, basically.
Basically, yeah. When the system is operating correctly, that condensation doesn't just fall to the bottom of the furnace cabinet to rust it out. It collects inside a specialized sloped pan within the unit.
Okay, so it catches the drips.
Right. And from there, it drains out through a specific fitting on the side of the furnace and enters something called a condensate trap.
A trap.
Yeah. Once it navigates the trap, it flows down a dedicated drain line. Depending on your home's architecture, that line either uses gravity to route the water to a nearby floor drain, or it deposits the water into a small external pump that actively pushes it up and out of the house.
So there's a whole internal aqueduct system managing this rainstorm, and I assume this isn't just pure neutral tap water running through those pipes, right?
You bring up a really vital point there. Because it is the byproduct of combustion exhaust, the condensation is actually quite acidic.
Oh, really?
Yeah, it has a pH level similar to vinegar or like a light soda.
Yikes.
So a properly installed system accounts for this by using specific corrosion-resistant PVC piping and vinyl tubing. If everything functions as intended, the water forms, it drains through the plastic channels, and it leaves your house entirely unnoticed.
Okay, so if I'm staring at a puddle, it means the furnace is still a genius, but the aqueduct is broken somewhere along the way. I want to figure out where that break happens. Let's walk through the space organically. If I see a puddle, what's the usual suspect right next to the machine?
The first major choke point is the condensate trap we just mentioned.
Okay.
A trap is essentially a low spot in the drainage system that deliberately holds a small amount of water. It acts as a barrier, preventing the furnace blower from sucking unconditioned air, or worse, dangerous exhaust gases into your living space through the drain pipe.
Right, right.
But because it sits lower than the rest of the line and it's constantly damp, it's perfectly positioned to catch any sediment, debris, or gunk that washes out of the furnace. So over time, it can grow a really thick biological slime.
Ugh, that sounds exactly like the P-trap under a bathroom sink.
It's exactly like that.
If you've ever had to take apart the plumbing under your sink because the water is draining painfully slowly, you know exactly what we were talking about. You unscrew that U-shaped pipe, and it's packed with a thick, gunky clog of soap and whatever else went down the drain.
Gross, but accurate.
So the furnace trap acts the same way. It plugs up, and because the furnace just keeps burning fuel and producing water, the condensate eventually backs up inside the machine and just spills out onto your floor.
That is an incredibly common scenario. The machine didn't break. A small plastic pipe just got clogged.
Such a relief, honestly.
Definitely.
Yeah.
Now, the next place to look is the drain line itself stretching across the floor. This system almost entirely relies on a gentle, consistent downhill slope to move the water away. Gravity is doing all the heavy lifting here.
Makes sense.
But over time, houses settle and things shift around in utility rooms. If that PVC drain line sags in the middle or loses its downward pitch because someone bumped it with a box, you have a problem.
Right, because gravity just stops working in your favor. If the line sags, the water just pools in that dip until the whole pipe is full, and then it backs up to the furnace.
Yep, nowhere else for it to go.
But what if gravity isn't an option at all? Let's say my furnace is in a basement where the floor drain is actually higher than the unit.
Then you rely on the third major component, which is a small condensate pump sitting on the floor right next to the furnace.
Oh.
The water drains into a little plastic reservoir box on the pump. Inside that reservoir is a float switch. As the water level rises, the float lifts up. When it hits a certain height, it triggers a small motor to turn on, sucking the water up a tube and shooting it out of the building.
It's kind of like the float in the tank of a toilet, just working in reverse to empty the tank instead of fill it.
That's a great comparison. But, mechanical things fail, unfortunately.
Of course they do.
If that tiny float gets stuck in the down position due to that same slime or debris we talked about earlier, the pump never realizes the tank is full. Or, the motor simply burns out from old age. Either way, the reservoir fills right to the brim, overflows down the sides, and creates your puddle.
So if you have a little plastic pump sitting next to your furnace, that should probably be suspect number one.
Usually, yeah.
This all makes total logical sense. It's the dead of winter, the heat is running constantly, condensation is forming, a pipe clogs, and we get a puddle. But here's where it gets really interesting.
Okay.
What happens if you find this exact same puddle in the middle of July?
Oh, this is a classic.
You haven't turned the heat on in 3 months, yet you walk past the furnace and there's water creaking across the floor.
This is one of the most fascinating misdirections in home maintenance. It completely fools people. If you find a puddle around your furnace in the summer, you are almost certainly dealing with an optical illusion. You're blaming the furnace for a crime it simply did not commit.
Defending the honor of the furnace.
Always.
But seriously, if the heater has been off for months and water is pooling around its base, where is the water actually coming from?
It comes down to the physical architecture of the HVAC cabinet in most modern homes. Space in utility closets and basements is usually at a premium, right?
Right.
So systems are stacked vertically. In the vast majority of setups, the air conditioning evaporator coil, that's the part that actually gets freezing cold to chill the air, it sits directly on top of the furnace.
Oh, I see.
Yeah, they are stacked in the same vertical metal cabinet because they share a single powerful blower motor to push air through your home's ductwork.
So they're basically roommates sharing a fan.
Exactly.
So how does the AC make so much water that it floods the floor?
To understand that, we have to look at how air conditioning actually works. An AC unit doesn't just lower the temperature of the air, it conditions it by actively ripping humidity out of your indoor environment.
Taking the moisture out.
Yes. Warm summer air holds a massive amount of invisible moisture. When the furnace blower pushes that warm, humid air across the freezing cold AC coil, the air hits its dew point.
Wait, so it's that cold window analogy all over again, just scaled up for the summer.
A much, much larger scale. That cold metal coil sweats profusely as it strips the humidity out of the air. In a humid climate, an average home AC can produce gallons of condensation a day.
Gallons.
Gallons. Now, that AC coil has its own drain pan underneath it to catch all that sweat, and its own drain line to whisk it away. But if that AC drain pan clogs with dust or, algae, the water has nowhere to go.
It overflows.
Right. It overflows the pan, drips straight down the inside of the cabinet, and pools right around the base of the furnace sitting underneath it.
Wow. If we connect this to the bigger picture, it perfectly illustrates how shared infrastructure in home systems leads to total misdiagnosis.
It really does.
You see the water touching the base of the furnace, so you naturally assume the furnace is leaking. But if your thermostat has been set to cool for months, you aren't looking at a furnace problem at all. You're looking at a clogged AC drain pan that just happens to be raining on your furnace.
It's a crucial distinction that saves a lot of confusion and unnecessary panic. Now, having solved the mysteries of high-efficiency winter leaks and the deceptive summer AC leaks, we need to shift gears.
Okay, what's next?
There is one very specific scenario discussed in the source material, where a puddle by the furnace is not just a plumbing annoyance, but a genuine immediate emergency.
Yes, the red flag. Dave makes this explicitly clear. Everything we've unpacked so far, the secondary heat exchangers, the intended condensation, the PVC plumbing routes, that all strictly applies to modern high-efficiency condensing furnaces.
All right.
But if you live in an older home and you have an older standard furnace, the rules are completely different.
They're diametrically opposed. Remember how we established earlier that older standard furnaces waste heat by sending hot exhaust gas straight up the flue?
Yeah, the one heating the outdoors.
Right, because that combustion gas is supposed to stay incredibly hot all the way out of the chimney, An older standard furnace should never, under any circumstances, produce liquid water. It just does not have the secondary heat exchanger to cool the gas down.
The visual cue for you, the listener, is very straightforward here. Look at the exhaust pipe coming out of the top or side of your furnace. If it's a traditional round metal flue pipe, like a hot metal pipe venting into a masonry chimney or straight up through the roof, you have a standard furnace.
Yes, that metal pipe is the giveaway.
So if you see that metal flue and a puddle of water on the floor at the exact same time, what is actually happening?
If you see water around a standard furnace, it means that the highly dangerous hot combustion exhaust is cooling down and condensing somewhere inside the system, or the venting where it absolutely shouldn't be.
Oh, man.
Yeah, this is the massive red flag. It points to a severe problem with the venting or the chimney draft. The exhaust gases might be trapped, or the draft might be stalling out due to some blockage.
Wait, if the exhaust isn't going up the chimney because it's stalling and turning into liquid, where's the rest of that gas going?
This raises an important question about safety, because that gas is spilling back into your home.
That is terrifying.
We are no longer talking about a clogged plastic pipe. We are talking about the safe removal of combustion byproducts, which prominently includes carbon monoxide.
The silent killer?
Exactly. When hot exhaust loses its upward draft, it cools, turns to liquid, and dumps highly toxic gases right back into the utility room. This crosses the boundary from a nuisance plumbing issue to a critical combustion safety hazard. This is never, ever a wait-and-see situation.
Right.
Dave is emphatic about this. Combustion exhaust problems require trained eyes immediately.
That is arguably the most important distinction in the entire guide. The type of vent pipe tells you exactly what kind of machine you are dealing with, and by extension, whether that water is an annoyance or a serious hazard.
Absolutely.
All right, so we know the mechanics of combustion, we know the summer optical illusion, and we know the red flag warning signs. Now, if I'm standing in a puddle right now, what is the absolute first thing I should look at without electrocuting myself or messing with something dangerous? Let's walk through Dave Hartzell's homeowner-safe troubleshooting plan.
The very first thing to do is establish the context. Note the season.
Simple enough.
Yeah, if it's 90 degrees outside and the air conditioning has been blasting all winter, start by looking up at the AC coil section above the furnace. That context alone solves half the mysteries before you even touch a pipe.
And if it's not just the AC tricking me, like I'm looking at the plumbing, what am I looking for?
You're looking for the obvious physical disconnects.
Yeah.
Visually inspect the drain line coming off the furnace. Did someone store a heavy box next to the unit and accidentally knock the PVC pipe completely off its fitting?
Happens all the time.
It really does. Or is there a noticeable deep sag in the line where water is just sitting in a U-shape, unable to flow uphill? Sometimes the fix is as simple as reattaching a slipped pipe or putting a block of wood under a sagging line to support it.
Next up, check the floor, right?
Yes. If you have a condensate pump sitting down there, give it a quick visual check. Is the plastic reservoir completely full of water? Is it making any humming noise, or is it just dead silent?
Because if it's full and silent,
then you've likely found your culprit, a dead pump or a stuck float. And, while you're down there staring at the equipment, just change your air filter.
always a good idea.
It's great practice and ensures the whole system has the airflow it needs to function properly.
That covers the safe visual checks. But equally important are the boundaries Dave sets. There is a hard line on what a homeowner should not attempt.
That's very true.
Do not start unscrewing metal panels to open up the internal furnace cabinet. Do not poke around the burner assembly trying to find the source of the water. And absolutely do not attempt to dismantle or tape up the exhaust venting. The goal here is safe, visual troubleshooting of the external plumbing, not amateur mechanical surgery.
I love how you put that. We are observing the aqueduct, not rebuilding the engine.
Exactly. So when have we exhausted our safe options? When is it time to just admit defeat and call in a professional?
Dave outlines a few clear triggers for that. First, if you check the drain, check the pump, maybe clear a little gunk from the end of the line. But the puddle just keeps coming back day after day. You've ruled out the easy visual stuff. Now you need a pro to check the internal traps and pans.
Right.
Second, and we really cannot stress this enough, if you have an older standard furnace with that metal flue pipe and you see water, make the call immediately.
Yeah, no messing around with that.
Do not troubleshoot. Just get a professional out there because of the severe carbon monoxide and venting safety concerns.
Third, if you're staring at a stacked unit in the summer and you simply cannot figure out if the water is coming from the AC coil above or the furnace below, if the origin is a mystery, let an expert trace it.
Good rule of thumb,
And finally, if the water has sat long enough or is leaking fast enough that it threatens to damage your floors, your drywall, or your belongings. When property is at risk, hand the problem over. As Dave points out, if you happen to be located in the Kingfisher, Oklahoma area, you call Hartzell's Heat and Air at 405-375-4822.
Knowing when to call for backup is a critical part of homeownership. With exactly 47 years of experience, a NATE certification, and a family-run operation, technicians like Dave are the kind of experts you want looking at these systems.
For sure.
But regardless of where you live, the overarching rule remains the same. Once you've safely ruled out the simple external plumbing blocks, calling a local professional is the smartest move you can make.
So what does this all mean? We started with a panic-inducing puddle in the basement, assuming the worst about a broken machine.
We did.
But as we've unpacked Dave's guide, we've seen that this puddle is really just a puzzle. If you have a modern system in the winter, it's likely a sign of incredible high-efficiency chemistry that just suffered a minor plumbing clog. If it's summer, it's probably a sneaky air conditioning unit sweating onto its downstairs roommate while stripping humidity out of your air.
And if it's an older system with a metal flue, it's a critical warning sign that your venting needs immediate attention.
It completely transforms how you look at the equipment. You move from a place of fear to a place of mechanical understanding.
You really do. And I think that leads to a really fascinating thought to leave on. As our appliances become incredibly efficient squeezing every drop of heat out of exhaust or pulling gallons of humidity out of the summer air, our homes are no longer just passive shelters.
What do you mean by that?
Well, they're becoming these complex, interconnected ecosystems where water, airflow, and electricity are constantly dancing around each other. The push for ultra-efficiency forces us, as homeowners, to evolve. We can no longer just be passive inhabitants. We have to become active stewards of our own complex microclimates.
We are the caretakers of an ecosystem. I love that. Understanding the physics behind that doesn't just solve a plumbing mystery. It completely changes your relationship with the quiet machinery that keeps your home running every single day. The puddle isn't a monster, it is just part of the process. Thanks for joining us on this deep dive. Stay curious, check your drain lines, and we will catch you next time.